Okay, so we were talking about section 5.8 last time in class, using integration tables to help us find some antiderivatives. And you've had some practice with that. As you know, under the course content folder, if you click on the course content folder, chapter 5, go to section 5.8, there's a link that will allow you to download the table of integrals. And so how many have downloaded the table of integrals? How many have done that? Through that course content link. Okay, good. And then, of course, there are links in section 5.8 that will give you access. Very good, Jen. Very good, Ange, and others. Let me see. There was a right. So, David, you will not have to print for part 2 of the exam. You will not have to print out the table for part 2 of the exam. I will make sure you can access that table, the table of integrals for section 5.8. You'll be able to access that electronically. Okay, I can upload that in Examity, and you'll be able to download that and open that up for part 2. So don't worry about that. I like the idea of having people print things, but not everybody has a printer. So okay, here is the integral. Here is the integral. And what do you think here? We have to look through the table. Okay, we have to look through the table. There are the table of integrals has 120 integrals. We have to find one that's gonna work. So go ahead and look through the formulas and try and see if you can find a formula that might work here. Okay. And if I bring up the formulas here, okay, that's the table of integrals. Under 20 formulas. All right, and we have to think about what formula is going to work. Now, naturally, to class, it goes without saying that these kind of problems, okay, you have to think about a substitution. Okay, and hold that thought, Sunday. Hold that thought. So if you were to make a substitution, a U substitution here, what do you think it would maybe be based on the tables that you see, the forms of the integrals? What substitution might be a convenient one to use? Yes. So, you know, that's right. Good, Nathaniel. Good, Taj. Good, Sandhya. Let U equal the log of 3x. Okay. So we're going to do that. Let me go to the next page. We're going to let U equal the log of 3x. Okay. Well, if U is the natural log of 3x, then by the chain rule, the derivative of U with respect to x would be 1 over 3x, and then the derivative of the 3x, that's your inner function, right? The derivative of the 3x would just be 3. And therefore, du dx would equal 1 over x. and therefore du is 1 over x dx. Okay. So in this integral here, this part here, the 1 over x dx becomes du, and this other part here becomes the square root of 16 plus u squared. Okay, and so, all right, and so now this then is our new integral. And so oftentimes with tables of integrals, and it seems to be section 5.8, it seems to be for some students difficult, but if you think about a good substitution, it helps you. And indeed then, Sandia, formula 21 would be the right formula to use. All right, let me give you a moment to copy. Okay, very good, very good. Let me give you a moment to copy down to this line here. All right, please let me know if you have any questions. All right, well, if we're good then on that, now we'll put back in what u was. U was equal, oh, I'm not going off the page yet. I'm not going off this page yet. U is equal to the log of 3x, and so now I'm going to substitute the log of 3x back in for wherever u was. See, this is an indefinite integral, so we have to then, since our indefinite integral was an integral with respect to x, we have to our answer, our final answer, which is our antiderivative, has to be in terms of x. And all right, so, and I'll let you copy that. I'll mention too, class, while I'm at it, I just came in my mind. So we are going to have a lecture on Thursday's class. The exam is posted after the class. But we will be using our class time to discuss new material on Thursday. So please, everybody should be attending on Thursday's class, 2 days from now. Let me see, I think there was a chat message here. Yeah, so if you can do and in regards to the exam, Sunday asked a question, if you can do the problems in your homework well, you should do well on the exam. Okay, you should do well on the exam. And remember, if you go into an assignment and view the key, then you click on near the problem. There's a practice another version if you need it. Also, so you have the ability to practice new problems. And don't forget the textbook. The textbook has problems too that you can do, and you should have odd answers. I know in the physical textbook you have odd answers, and I hope in the ebook I hope you would. But it's okay. You can just go into the WebAssign, right, and practice that way. Yeah, I let you study for the exam. You tailor the stuttering the way you're studying, the way you need to study. Okay, but if you're comfortable with the homework, and you're doing the homework, you're doing the homework and all that. Um, I think you should perform. You should do good on the exam, well on the exam. Um, all right, Sandia. Um, okay, let's go to the next question. Excellent, excellent. Thank you, thank you. Very good. All right. Are there any questions on our answer here? Okay. Well, then let us proceed on. Let's do one more problem. Let's do one more problem here. Let's look at this problem here. Okay, so we want to find the antiderivative of 5 times the arc cosine of the square root of x dx. Okay, so the table of integrals should have something. It won't be a perfect match, but go through the tables and see if you can identify a formula that might be a candidate here to help us find the antiderivative. Okay, wait. Okay, Xavier's saying formula 88. Okay, that certainly is a possibility. So we need a formula naturally that involves the arc cosine, and Mario's saying maybe formula 91. Okay, that's a possibility. Okay, and it takes a little time to think things through, right? Okay, so arc cosine, that's also notation. Right, and the 5 I'm going to pull out in front, right? Okay, so D'Angelo, Ange, Mario, and Xavier are thinking formula 88 or 91. And it can't be both, right? So let's go ahead and let's look at the solution and see what's going to work. Okay. Well, Sandia, Sandia is saying, okay, let u equal the arc cosine of the square root of x. So you're recognizing a substitution is going to have to be made. I would be more comfortable with my substitution just being the square root of x. Yeah. Your substitution, you want it to be an easy one. All right, let's first of all deal with the formula. So here are the two formulas. See, I actually anticipated that students would say either formula 88 or formula 91. Okay. But formula 88 would, I want to be a little bit careful here. Formula 88 would not be an option because you see, our integrand is the arc cosine of the square root of x. And you see, the formula 88 just has the arc cosine of u. So like if you had the arc cosine of x, that would work, but you don't have that. You have the arc cosine of the square root of x. So you're going to have to make a substitution. And when you make a substitution, that's going to generate something else in the integrand that you need to deal with. So formula 91 is the right choice. It's the right choice. You see, the u in formula 88, the variable u, du, we don't have that. We have, for our integral, we have the, 5 times the arc cosine of the square root of x dx. So we don't have, we don't have x dx. We have square root of x dx. So this formula 88 won't work. It's going to have to be, we're going to have to try formula 91. Okay, but if we right away did the substitution, u equals the square root of x, you would see that formula 91 will be the right one to use. So that's why I'm always saying it's kind of a, you look over the formulas and try to find a neighborhood of formulas that's going to work, but don't be 100% committed in your choice, because you have to make normally you have to make a substitution, and then see what happens. Okay, so let's go ahead and make that substitution. Let's go ahead and make it. We're going to let u equal x to the half power. So I just wrote the square root of x as x to the half power. Okay. Well, if we do that, then du dx is going to be 1/2 times x to the negative half power. Du will be 1/2 x to the negative half power dx. Okay, and let me just see here. Let me go up here. So here I have the arc cosine of u, but now what's dx going to be? What's dx going to be? Okay, what's dx going to be? Well, all right, let's find out. So I'm down here on this step, and I want to get the dx by itself. Okay, and so that means I don't want the half there, and I don't want the x to the negative half there. So what do? I'll multiply through by the reciprocal. I'll multiply through the equation by 2 times x to the half power. Okay, and you have 2 times, on the right side, you have 2 times x to the half power times, times 1/2 x to the negative half power. That negative 1/2 I wrote a little big here. Let me do that, fix that. Negative 1/2, okay. So this is 2 times 1/2 times x to the half times x to the negative 1/2. Well, 2 times 1/2 is 1. X times x to the half power times x to the negative half power is x to the 0th power, because that's 1/2 plus a negative 1/2. And x to the 0th power equals 1. So this is just going to equal x to the 0th power, but x to the 0th power is 1. And so you get dx equals 2u du. That's going to be what dx is. Dx is 2u du. And so then this is going to be your integral. Okay. And I'll bring the 2 out, and I'm down here. And so that's a match. This integral is a match with formula 91. Okay, that's a match. Are there any questions up to here? All right, well, we have an antiderivative. Let's see, could you simplify? You could. So of course, we have an indefinite integral. So since u is equal to the square root of x, I have to put the square root of x back in where every place where the u is. But as Sandia noted, I mean, I could type all this in WebAssign, but you know, the square root of x squared is just equal to x. So I can simplify this, right? I can simplify this. And I'll show you the, I'll give you a moment here. I'll show you the simplified answer on the next page here. But the square root of x squared, wherever you see that, you can just write an x for that, right? Are there any other good comments or questions? I want to make sure I'm pacing myself okay too before I go to the next page. How many are feeling good so far? Good. Tosh is good. Mario's good. Ange is good. Xavier's good. All right. Okay. Well, then let us proceed on here. So this is our antiderivative, and let me just see one thing here. I want to go back for a moment and just see one thing. Oh yeah. So right, this here becomes 2x minus 1 over 4, right? That's going to be 2x minus 1 divided by 4. And then this here is just going to be 1 minus x inside. So that's fine. That's fine. That gets us here. And I can even do a little more simplifying if I wanted, you know. Like, for instance, the 10 can be, you know, 10 and 4 reduces to 5 over 2. So we want simplified radical form, not decimals. WebAssign, you know, if WebAssign will tell you when it wants a decimal approximation. So, like on the exam, for instance, if it doesn't say you use a decimal and you put in a decimal approximation, it'll count it as wrong. All right. So, you know, simplified radical form is normally the standard of what WebAssign wants. Okay. So really quite a lovely problem. It's actually quite amazing that the antiderivative of 5 times the arc cosine of the square root of x equals this expression on the right here. It's really quite amazing. But this is the beauty of having these tables available to us. It allows us, you know, it allows engineers, when they have to do integrals, it allows them to it saves them time. Okay, it saves them time. And like my father, for instance, when he was in college, he had a table of integrals that he used for his engineering classes. It saves time, you know. It's okay. So, are there any questions? My father, Mario, he was a electrical engineer. That was his. Well, no, I want to be. He was an electrical engineer, but he had training also in like fluid dynamics. That's where his expertise was in fluid dynamics. He actually got a PhD in that, and you know, good guy, good guy. Yes, yes. Uh, Thank you, Ange. Thank you, Mario. Yeah, yeah. And, you know, I know many of you are in engineering or want to be engineers or scientists, or, you know, I became a statistician. That's my area of expertise. And we all do things, but all the things we do in science, they all involve math, right? So, um, okay. Are there any other good questions? All right, I'll stop the, yes, yes. Um, yes, Sandia, you're good?
Yes.
Excellent, excellent. Okay, I'll stop the recording.